السلام عليكم. Hello everyone
السلام
to our
عليكم.
webinar today. أهلا إسلام، أهلا أبو عمر، كيف حالكم؟
نعم رحمة، أهلا وسهلا.
هلا والله. طيب السلام عليكم. Hello everyone and welcome to our webinar today about the future of the video analytics today. My name is Akram Badruddin. I'm glad to be the moderator for this session. Before we start, I want to share a quick thought on the topic today. Many years, video was just a way to record what's happening in the past. If something went wrong, we will go back and watch the tape. But today, because of the AI, that has completely changed the game. Video is no longer just recording the past, it's understanding the present. It can see problem, understand what's happening, and alert us immediately. It's a huge jump forward. And that's what we are talking about today, inshallah, with our panelists today. Let me introduce you to the panelists. I'm glad to have Mhandis Islam Ahmed, Senior Staff Software Engineer from AvidBeam. أهلا إسلام.
أهلا أكرم. أهلا.
أكيد عندنا أبو عمر طبعا our gig in AI, our Director in AI and Data Emerging Technology Solution by CC. أهلا أبو عمر.
ياك أكرم, Islam and everyone.
طيب. Before we start, I would like to hand over to Islam to introduce AvidBeam to us, and we can start after that.
Okay. Hello and welcome everyone. So about AvidBeam. So AvidBeam was founded back in 2014 by former Intel professionals, and it's headquartered in the Netherlands. We deliver AI-powered video analytics that's based on computer vision, big learning, deep learning, and big data architectures. Our system is highly scalable and fault tolerant, and it puts a lot of emphasis on hardware optimizations and big data architectures, as well as integration flexibility. Certified by both Intel and NVIDIA, AvidBeam integrates with leading video management systems, IoT systems, and holds a strong regional reference and industry awards. That's AvidBeam in a nutshell.
Great. Thanks, Islam. طيب, let's start from the beginning. Can you tell us and take us back to the analog era? Because we need to understand that after we go through it.
Of course. So what we got for you today is the evolution of video analytics. This is what we're going to talk about, one item of the agenda. And the first part of this evolution is the analog era, and it spanned the 1990s. And you can imagine the technology that they had back then. It was based on traditional VH tapes and CCTVs. It was limited to just this. Muhammad, can you tell me what kind of analytics that would you expect that they had back then?
Well, back in the 1990s, I would think it's going to be manual. So it's going to be only humans, security engineers.
Exactly. Yeah,
a lot of changes,
right.
Until today.
Exactly.
So Tom and Jerry, so I think it would.
I guarantee a lot of the new Gen Z, they don't know about some things that you're gonna mention, Islam.
Yeah, exactly. What is a VHS tape? So exactly, they had no kind of automated analytics back then, and they only relied on the pair of eyes of a security guard and their attention. And of course, we're talking about human attention here, which is known to dwindle dramatically within almost 30 minutes. If we're talking also about the limitation of such technology, we had no ability back then to search or filter automatically. One had, to perform fast forwarding or rewinding through hours of tape. So this is the first part of the evolution. The second part of the evolution, it's based on pixel-based motion detection, and it spanned the 1990s until early 2000s. The technology witnessed a shift from analog video to digital video. So now we're seeing, bits and pieces, zeros and ones, and so on. Of course, the notorious computer vision library OpenCV, it was initiated by Intel and released the beta version back in the year 2000. And this computer vision library, it served as the cornerstone for advancing computer vision algorithms by the industry. Back then, it had the ability to compare pixels and figure out, motion detection should a percentage of pixels change on the screen. And of course, lots of software appeared back then that leveraged this kind of technology in order to, for example, trigger a recording or an alarm should a motion be detected. So this is a very basic form of analytics. It's just based on basic motion detection. And of course, you can guess what kind of limitations that they had back then. Everything that moves in the screen is going to actually be an alarm. So if if there's a shadow, if there's a tree moving around, it will be detected as an alarm, and then the security guard would be, oh, what happened? What happened? And then eventually they will start ignoring those alarms. And of course, we had also an ability to still figure out or classify objects or detect objects back then.
How was the performance, Islam, at that time? Was it like immediate because pixel is changing and you can detect that, or does it take time to alarm it?
Well, actually, definitely depending on the hardware that they had or that they were using. We're talking that CPUs weren't as powerful as today, so I would imagine that they were using definitely a low frame rate was being used. So I wouldn't think that it was immediately slow, because back then also video resolutions were not that big, and then of course you are able to tell whether or not a series of pixels changed on the screen in a very small amount of time.
It wasn't only the software; it was also the cameras, the equipments themselves.
Yeah, exactly, because this is what you're analyzing. You're analyzing the feed from the camera. So the amount of data that you have or you need to process is definitely a factor here.
It's good to know.
Yeah. Right. Let's talk about the next step in this evolution. It was about features and embedded analytics, and this era or period, it spanned the mid 2000s until the year 2010. Regarding the technology, NVIDIA, they released CUDA toolkit back in 2000, and they started a revolution basically because they allowed researchers to use graphical processing units for general purpose math. And this, it wasn't possible until then. We also started seeing various computer vision algorithms that would look like for certain aspects or features or shapes on the screen in order to detect objects. So for example, you can, for example, imagine, that the human mouth is just a horizontal line, and then the nose is just a vertical line, and then a set of features or cascade classifiers can be made up in order to detect such objects. As for the hardware, since CUDA was released by NVIDIA, we started seeing more GPU units hitting the markets, and of course, we're talking about embedded analytics or processing at the edge. We started seeing cameras performing basic computer vision on chip in place at the edge, embedded within the IP cameras.
So Islam, just to correct me if I'm wrong, also when you're talking CUDA, we're talking about the Compute Unified Device architecture, right? Where NVIDIA has created this model for developers to start using the GPUs rather than only CPUs, not only for graphic, now for also compute, right?
Yes, exactly. That's correct.
Okay.
All right. So as for the analytics part that was available, due to the existence of cascade classifiers and detectors, we started seeing object classification finally to appear of people, cars, animals, and so on. Also, advanced rules enabled more advanced analytics, such as, for example, loitering detection, which is a person staying within an area for too long, left or removed object from the scene, and directional movement made for wrong direction driving. So back then, lots of cooler analytics started to appear. And of course, for example, you could also, perform people count in stores and so on. This form of analytics was available. Now let's talk about the limitations of such technology. Heavy object traffic introduced occlusions, partial occlusions, scene challenging, scene challenges and varying angles for such objects. Introduced the accuracy of this generation of detection. And of course, objects, they became harder to detect in these kinds of environments.
Interesting.
Yeah. Yeah, and now let's move to the next part of the revolution, and this is where it gets more interesting actually, and it's about the neural networks and the deep learning, and it started basically back in 2010, and it's still present with us today. So about the technology, now actually NVIDIA created the Big Bang. Hamad, can you guess what kind of Big Bang they created in this particular era?
I think I remember seeing all there for video analytics. This is the Big Bang by NVIDIA, and I think it's the powerful of the new GPUs and the creation of the new.
Exactly. Yes, exactly. It was all thanks to the parallel nature of GPUs, enabling a massive speed up over CPU implementations, because the GPU is basically the perfect tool to process thousands of video pixels on the screen in a very short amount of time. See, through neural networks and convolutional neural networks, which they are based on basically imitating the brain learning process, for example, supervised learning, where you need to train your neural network or model in order to understand the object of interest. So through these kinds of models, the machine started to have a higher capacity of learning by basically training on millions of examples of what an object looks like, resulting in increased accuracy. And you can see actually from the picture being depicted, this is the kind of detection that you can get, and accuracy. You can see that it's able to detect even distant objects in the scene, partially occluded, or even different angles from the objects. Google also they released TensorFlow back in 2015, and this basically set the gold standard for deep learning R&D, which set off a race in the industry in order to train the best models and refine them and achieve the perfect mean average accuracy. And of course definitely some other models, they left their mark, like YOLO Darknet. That's it's a very popular model in the community. Microsoft Research, they also created ResNets, or residual networks, which is a breakthrough architecture that enables greater depth of neural networks, resulting in improved accuracy. Also, they co-developed ONNX model formats, and this was to ensure that any model trained in any framework is able to run on any hardware, be it Intel CPUs or NVIDIA GPUs, which actually accelerated the deployment of R&D into production.
One thing, Islam, back to the Big Bang, and this is maybe for those who lived the era of the early 2010, where it was all about gaming and those gamers, as you call them. So whenever you mention GPU, they only think graphics. So I could enhance the resolution of the game. So I need a better GPU to my PC, to my laptop, and so on. But the Big Bang happened actually, I remember, if I remember correctly, in 2012, where the developers of CUDA started using GPU for compute.
Exactly. Yeah.
This was actually the Big Bang of the usage of GPUs rather than only for graphics and games and resolutions, which made the Big Bang being called, and then it grew bigger till to 2018, and then as we witnessed with GPT and so on, how we're using GPUs as powerful compute and parallel as we use it today.
Indeed. Yeah.
Interesting.
Good note back to the Big Bang. So because people from shifting from gaming now to parallel computes, which GPUs allowed us, and CUDA mainly from NVIDIA, that made this difference.
Indeed. So let's see the analytics that was made available by neural networks and deep learning. Of course, you get very high detection accuracy of objects exhibiting low lighting conditions, for example, or in varying angles. You are able to perform attribute extraction. For example, you can search for the blue car, the white car, the gray Hyundai, and so on. Man with sunglasses, you're able to perform this kind of analytics, or even cloth color. You can search people by their clothes. Facial recognition, of course, which is on the fly matching of faces against a database of people. Now let's talk about the limitations real quick here. Definitely, it's a lot more computationally expensive compared to older techniques or classical techniques. Data, we need more data. So, if you have any particular problem that you want to solve with NNNs or CNNs, you definitely need to have a good pool of data, labeled data or unlabeled data, depending on the context. So without data, you are unable to solve the problem at hand. GPUs are again often required, and this is due to definitely the Big Bang that we talked about. GPUs are often required for both training and real-time inference, which basically takes us to the next step: commercial adoption. It definitely requires optimizations of the hardware to reduce the total cost of ownership.
100%.
All right, and now let's talk about, finally GenAI, and this one we will cover a little bit more. So let's actually understand, how it all started. So everything was almost everything started back in 2017 when Google released a paper called "Attention is All You Need." This paper, it was based it introduced the transformer architecture, and the transformer originally presented in this paper, it had to do with translation. It was mainly trying to translate French to English and English to French phrases. So let's talk about the transformer architecture itself and what it is. The transformer architecture, it's a breakthrough architecture that excels in parallel processing of sequential inputs such as text, while still being able to capture long-range dependencies between the words in a sentence, and still being able to disambiguate those words. Basically, the transformers architecture includes three key main innovations that made this possible. The first being, it's called positional encoding, and positional encoding, it's a it's a mechanism that teaches the network the importance of word ordering. So for example, if you have a sentence, you just assign a numeric value to every word in the sentence based on its orders, 1, 2, 3, and so on. So this provides the network with the ability to understand the importance of word meaning in a sentence. The second key innovation is called attention, and it's a mechanism that you see a lot nowadays in machine learning, and it's also a mechanism that gives the neural network the ability to reference or attend to the input while generating the output. So picture, for example, you're trying to translate a sentence from English to French. So most likely when the network is trying to generate the fourth French word, it would be looking at the corresponding English counterpart. And this could be, the third, the fourth, or perhaps the fifth English word in a sentence. That's what attention is. The last key component, it's called self-attention, and it's the most important one, actually. Self-attention is a twist on regular attention in the sense that it's a mechanism that allows the network to understand word meaning in the context of the words around it. Let me give you an example. So consider the following two sentences. The first sentence being, server, can I have the check? And the second sentence is, looks like I crashed the server. Mohammed, can you tell me what is in the first sentence that made you say, oh, the server here is an actual human server rather than a metal server?
I think when it starts to think, it's like detecting. It's not just being labeled. It would understand the whole content and sequence. So now it's neural networks. It's thinking like how humans are thinking.
Yep, exactly. It's the key idea behind generative AI. It's to mimic the human thinking process. And how would you go about this? You would go, oh, there's a check basically in the sentence. So the neural network is able to say, oh, there's this check in the sentence, so I will be able to disambiguate the server to be the human server or the waiter, for example. And in the second sentence, it's going to attend to the word crashing in order to figure out that this is an actual metal server, that was crashed. So those are the key main innovations. And it's through these innovations that the network is able to understand tenses, grammar rules, plurality, and all this kinds of stuff. So basically, transformers, and then afterwards, large language models, and vision transformers, and multimodal AI, this basically enabled a big shift towards scene understanding and language understanding as well, and enabling the why reasoning of things. So it's no longer just objects. The network is able to understand scenes very well and be able to also, give reasons to its answers. Another part of the revolution is Intel is it's moving R&D towards AI PCs through optimizations based on OpenVINO to be able to run those kinds of neural networks on Intel CPUs or discrete GPUs or integrated GPUs and even neural processing units.
If I may add to this, Islam, and I think just to simplify the idea how technology has evolved. So before with video analytics, it was about detection and rule-based model.
Yep.
With the transformers and the evolution. Now we're understanding the scene. It's like it's thinking, it's witnessing.
Yes.
It's not human has passed by and it detected it. However, now it's understanding that this human has passed by. He has been walking for 2 minutes in here and then did some behavior and went back. So now with the transformers, they could understand exactly how we interpret the behavior of something happening through videos.
Indeed. That's correct. Okay, moving forward for the analytics that was made possible by such technology, like Mohammed said, you are able to answer, for example, since the neural network has gained understanding of the scene, it's definitely able to understand a question like, is it safe to cross the street? And actually, if I ask you, Mohammed, how would you interpret safe to cross the street? What safety means?
There is no cars in the street, so I won't be hit if I pass by.
Of course, this is one idea, and because actually neural networks or large language models, they have seen way too much. They are trained on mountains of raw unlabeled data. They can actually interpret safe by meaning there's no fire in the street, there is no tree blocking the road, there's no car accidents. So all of this can be understood by the AI model just once you write the word safe. Likewise, it can understand, if you tell it detect or alarm if there's any kind of danger. So it understands that danger could mean a fire, danger could mean an accident, and so on. You can use it, for example, in factories to detect any kind of liquid leakage and so on. Suspicious even activities or anomalies can also be detected by GenAI. You can also inject videos for context. And then perform behavioral analysis. What's happening in the scene? Is there a fight? Is someone falling? Someone's been hit? There's a theft going on, and so on. You could also write a text summary for a 24-hour video very easily.
100%. It made me think a little bit, Islam, when you talked about safe and how we humans interpret things different than how with the power of now with the evolution and everything that's happening in tech-wise. So sometimes technology may think differently because they're looking at all aspects while we're thinking, for me, if you ask me now, is it safe to pass by? I would look at cars. I wouldn't care about anything else, right?
Yeah.
But maybe I'm wearing a glass with cameras and it has all that connection to, let's say, powerful video analytics to tell me, no, don't pass because there is a guy hiding behind the tree or there is someone with a gun in there. I couldn't witness this because my focus is on cars while it's processing every suspicious behavior around you.
True, definitely, and this is because of their generic nature and being broad. Because again, they are trained on mountains of unlabeled data, and you can actually guess they are trained on the web. So so you can guess what kind of information and what kind of relations that they can perform with respect to any questions that you're asking.
This is the next level that we're not seeing today. Maybe it's not going to be a necessity. It's going to be something that is heavily
relied on. Yeah.
Something you cannot live without.
Yeah, at some point it's definitely going to be like that. This technology, it's still emerging. It's getting there, definitely. Yeah, and definitely, hopefully, one day we should see it, being adopted everywhere.
We'll see what happens in the future. Back to the
yeah, definitely. Yeah, that's the interesting part. Now let's, discuss the limitations. Inference and training, compared, for example, to neural networks and deep learning, it requires a humongous amount of hardware, and we're going to see in a few minutes why it's that. And so far, they are not suitable for real-time analytics. If we're talking, frame-by-frame basis, they are not suitable for that just yet, making it challenging for commercial adoption.
But we're coming there.
Yeah, interesting. But I have a question here.
Yeah, go ahead.
It sounds incredibly powerful, but I have a question. What about the cost and time to train these massive models? For me, I feel like I scared. Like,
Yeah.
I think it's very expensive. It's like it's gonna take more time.
Yeah,
Tell me.
that's definitely an interesting question, Akram. All right, so let's actually see, we're talking about the humongous amount of time, hardware. Let's see why is that. See, in this graph here, you can see that the y-axis represent the amount of data size that's needed to train such models. The y-axis is in log scale. I'm not sure if it's pretty clear or not. But for example, the original transformer, when it was released by Google, it was only trained roughly on 200 to 300 million words. For example, also the notorious ChatGPT or the GPT model, GPT actually, it stands for Generative Pre-trained Transformer. So now what transformers are actually doing. GPT-3 was almost trained on 1 trillion word, while for example, GPT-4 was trained on 13 billion token or word. So you can see that the amount of data that we were talking about earlier, so they have physically seen way too much.
علم الإنسان العالم يعلم والله. A lot. Okay.
If we're gonna take a quick look at the training time, see the original transformer, since the one that was released by Google, it was actually purposed just for translation, so its training time didn't amount to much. If we're talking about GPT-3, for example, and this is one of the most notorious models out there. When it first came out, we were, whoa, this model could do this and that, and you can actually chat with it, and you can see the amazing things that's able to perform. It was trained on almost 34 days, so it took almost a month just to train this model.
Interesting.
While, for example, GPT-4, you need 100 days, so in order to be able to just train this model. And actually, GPT-3, it was trained only it was trained in a month using 1,000 using 1,000 NVIDIA GPUs, the V100. Actually, moving to the cost, and let's figure out why it's expensive. GPT-3, it required $4 million US to train.
Wow.
That's how expensive it is. Yeah. Moving forward, you can see GPT-4 almost requiring 20 times that. So it required $80 million US to train. Now you can see actually, one of the most powerful models out there, it's the Gemini 1.0 Ultra. Its training cost took almost $200 million in US. So again, you can understand why this technology, it's quite hard to tap into, quite hard to maintain, but definitely over time it will get there. All right. Now let's move on to generative AI and video, and that it's actually it's about time we define what is GenAI properly. So GenAI it's just an umbrella term for transformers, large language models, diffusion models that can generate text, images, music, videos, and more. Those models, they were also called foundation models, and they're called foundation models because of the amount of data that they train on. They train on mountains of unlabeled data for unsupervised learning. So, for example, in this depiction that you can see, you just prepare texts, paragraphs or series of images, speech, structured data, 3 things, and you just feed it into those foundation models, so that they would learn or interpret the underlying of the language or the underlying meaning of images and speech and so on. And this is the unsupervised part of the training. And then those foundation models can be repurposed or adapted in order to perform a specific function, be it chatting, answering questioning, or image captioning, and so on. And this is the supervised part of the training stage. Going multimodal, see, multimodal, it basically refers to having multiple types of inputs. So those foundation models, they also gain the ability and have expanded to process and generate text, video, and so on. And this is basically what makes them multimodal. You also have, for example, a good example of multimodal models or multimodal AI. It's called vision language models, VLMs for short. And those are basically one type of multimodals that can process and understand video, image, and text. So for example, you feed the image and then you feed a query to it. So those are two different types of inputs. And then the network might respond in just, plain text or even produce a visual output. Let's actually, discuss quickly, the pros and cons of this technology, be it, vision language models, which is actually relates more to our topic today. For the pros, they are highly generic and broad. Again, because they are trained almost on the entire web, depending on the model that you have at hand. So they have simply seen way too much information. You are able to write queries in natural language when you're trying to talk to them. They shine at solving subtle problems that are hard to limit to their specifics. So you can, for example, if like we explained earlier, you just need to say, alert me if there's any danger in the scene. You don't have to write, alert me if there's, any fire or anything. Danger would be automatically understood by the neural network. It's suitable when time to market is limited and critical. This actually refers to the fact that CNNs and NNNs, they require, again, data. So if someone approaches you with a problem that you don't have data for, you wouldn't be able to solve it, in a very short amount of time. However, if you can, grab today a GenAI model and then perhaps ask it or find the correct query to solve your problem. So it definitely solves, it's able to solve the problem when you're short on time. It's definitely suitable when near real-time performance is required, which is basically processing one or more frames in a specified interval. And this is because, of course, of the amount of hardware required by this technology. Now, as for the cons, they are definitely the counterparts of the CNNs in this criteria almost. Training, again, is very compute heavy. Like we mentioned, GPT-3, it required 1 trillion word in training. Training, it took almost a month, and it required 1,000 NVIDIA GPU for training. Inference cannot be performed on a frame basis, like we said, due to, of course, the involved latencies and complexity. It also will require definitely a prompt engineering, careful prompt engineering. And prompt engineering, it's all about, input structuring in order to incentivize certain outputs. So, for example, you see now, you see how people, might talk to GPTs nowadays. For example, you're an expert in video analytics. Do not make mistakes. So you try to actually guide the neural network or guide the model into exactly what you want to do while talking to it. And of course, we've seen definitely responses from GenAI models that we call hallucinations. And hallucinations are incorrect responses. Again, we definitely, if you're using, for example, ChatGPT or any kind of GenAI, you would see, a label down below, AI can make mistakes. It's because of the hallucinations. And they are simply incorrect responses because basically the model is trying to predict the next set of likely words rather than checking the facts. And of course, there are techniques that can help combat hallucinations, such as definitely prompt engineering as well as retrieval augmented analysis.
Interesting, Islam. Very clear. Now, before we move to the next slide, I would like to ask Abu Umar, based on what Islam just shared, what's your thought on the current use case and the demand we are seeing in the market today for the video analytics?
Coming to use cases, there is difference between video analytics and, as explained very well by Islam, thankfully, the GenAI video analytics. We're seeing lots of demand when you're talking about analyzing traffic, you're talking about analyzing certain behaviors, especially when you go to construction side or civil side, or even some areas where there's industrial areas. You need to check, are they wearing the safety? Are they doing something wrong? Did they forget to do something? All these now as video analytics need to be analyzed and alarm or take certain actions or give insight to securities team to make the proper action. There is quite some demand around these areas, to be honest, and there is so many companies reaching out to check what is required to develop or implement something like this. Because if you think about human safety, for example, if someone's forgetting to wear their vest or their hand, happens because we're humans, we forget about it.
Indeed.
So these type of things with video analytics is making a great difference. They would save companies lots of money when you're talking about, let's say, someone forgetting to do something, a problem is happening. I don't want to mention certain customers, but a problem is happening in certain industrial areas. It's causing lots of damage, causing lots of loss. Let me tell you about some behaviors of people when you're trying to go, for example, theft. For example, I want to check if someone has stolen something. For example, this is you can detect. Now, for GenAI, there is not much demand as of today, but what we've seen or we've witnessed or we had discussions around, some people want to discuss immediately with the agent, AI agent, about a video that is happening right now in a live feed. So they're having there is, let's say you're seeing a video and some people in your workplace, they're fighting together. And they want immediately to check and investigate this. What happened? They talk to the agent. What happened? Who started this? What do you think?
Exactly. Who started it? Yeah, exactly.
So these GenAI use cases, which I'm sure Islam will dig deeper on these type of things, I think it's gonna come in the future because we want to detect, we want to investigate, we want to get these type of let's say insight before either after after it happened, or even while it's happening. So it would help rather than having a human. Just imagine if you're having these live of 1,000 or 2,000 of videos, cameras around the place. You cannot have much human to surveil all those type of things. So if you're having powerful engines, you're having powerful machines doing this analytics, could predict or alarm immediately certain behavior and start talking to it to stop it, then this would make a huge transformation in our way of thinking in the future when it comes to this. I don't want to take much time on this.
Indeed.
Thank you, Abu Umar, but I'll guarantee you, not Islam who started that, I'm sure. That's great perspective, Islam. So let's look at some of this real-world example. What are the key use cases across different industry? Yalla.
Okay. Right. So, one, like actually Muhammad was referring to, one cannot easily, imagine the entire extent of what's going to happen for GenAI in the future, or the amount of use cases it will be able to solve, because we are the one who are writing the prompts. So again, like Muhammad said, who started this? This was his, simple natural language query. It was who started this? He just wrote this, and then the AI would figure it out. So unleash your imagination. So for example, we do have here today a select few of the use cases. So for example, you can use that or leverage GenAI in smart retail. You can use it to monitor customer behavior or figure out if you have a customer left unattended and so on. Structure compliance, definitely GenAI can, for example, detect building cracks, cracks and more. Urban safety detection of trash, rocks, fog or unsafe weather conditions, all made possible by GenAI.
Let me take the audience, or at least you, Akram Islam, with some imagination that I'm thinking of. Imagine, and this has happened to me actually in one of the cases, but similar case, I will not mention the same case. Imagine if you had you got something stolen out of your backyard or by your store and something like this, and you did not know when it was stolen.
what would you do? You need to go to the last 30 days, maybe the last 60 days, maybe the last 10 days, you never know. And you can keep track every second till you reach to that stage. Now imagine if I push this video feed to AI and I tell it, check for me who did or when it was stolen. So it would go through all the minutes and all the seconds. And I think with the power of GPUs today and the power of compute, it could do it in very quick manner. It may not need to take us days. Now it may take hours, it may take minutes till it finds out exactly what happened to this item. So imagine like 13 days ago at 9 p.m., someone passed by and just took the item and left. So instead of going through the live feed, now GenAI can help you go through it, understand it, and exactly take you through where the incident has happened. So this type of imagination, you can apply this thing in the future for anything, and it would result in great value, along with lots optimization in human, let's say, hours to investigate or to find out or whatever it is the case that is. So this type of imagination is very great for our audience to think of, and
Yes.
hopefully AvidBeam and AvidGenAI maybe in later stages, it might be the right tool for you. Back to you,
Yeah.
Salman.
Yes, and actually to add to what Muhammad just mentioned, it definitely see, like we talked about, the evolution of video analytics, and what actually AvidBeam excels at, it excels at, using the right tool for the right task at hand. So for example, Mohammed mentioned that the GenAI, would go through, a month of tape and so on. Actually, at AvidBeam, we even tend to mix the techniques. So for example, we can trigger the GenAI only when, there's something suspicious or there's a person, within approached this area or intruded in this section, and then the GenAI definitely can help you. Oh, this particular person, performed the actual stealing of such object. So mixing and matching the techniques is key for for AvidBeam.
Okay.
So
Next.
we're going to talk about next. We do have going to talk about AvidGenAI. So AvidGenAI is AvidBeam's video to language intelligence. It's based on GenAI, and it applies broadly across sectors, including smart cities, railway stations, oil and gas, sports, data centers, smart buildings, and more. So, and actually, let's just jump in action and see what AvidGenAI can do. So the first use case that we have here is a retail use case. AvidGenAI, it transforms retail by monitoring staff, customer behavior, and store layout. So you can set the query in natural language, and the query here says, is there any active worker? So AvidGenAI, it would respond with a visual detection of what it has seen, and also a natural language description of the output. So if we move forward, you can see the response of the neural network. Basically, AvidGenAI responds, the question was, is there an active worker? And now you can see the answer is yes, there's an active worker visible in the image. The worker is a man wearing a neon yellow safety vest and a long sleeve maroon shirt. Remember why, or remember when we mentioned that these kinds of or that GenAI would reason about its answer? Now, the AI model is going to tell you why he's active. He appears to be in the process of moving black crates filled with lemons through a produce aisle in a grocery store. This action indicates that he is an active worker. So, now you can see the answer of AvidGenAI. For the next use case that we have, it's about structural compliance use case. AvidGenAI is able to detect structural defects, alignments, material quality, and compliance. So, for example, you can ask it to, set alarm on objects. So in this example, it's trying to detect concrete honeycombing, and concrete honeycombing, it's when you have cavities or voids in a hardened concrete. So again, AvidGenAI would respond by detecting honeycombing, and then will give you a natural language description. So it says the scene depicts a concrete pillar at a construction site. The pillar is the central focus, showing significant signs of deterioration. So the network understands what honeycombing is, and it's showing it in the answer. The next case, it's about visual pollution case. AvidGenAI is able to detect various types of visual pollution. You just write the word visual pollution and it would understand what visual pollution is. For proactive, this is of course for proactive urban cleanliness. So again, you just set an alarm to detect visual pollution. And if presented with an image, that has any kind of rubbish or trash or and so on, it will detect it and it will even explain what is in the trash. So it says the scene depicts a large chaotic pile of garbage in a forest setting. The garbage consists of numerous black trash bags filled with various items and so on. So again, the network is able to actually figure out, what is in the trash and even, give actually put attributes to them like colors, what kind of trash is found. And this, of course, this definitely can be leveraged if you're trying to look for a certain item or look for anything that's lost. The last use case that we have for today is road hazards. AvidGenAI enhances road safety by detecting hazards and providing timely alerts. Again, you just write, write that you want to fire alarms on dangerous roads or rocks. An image is fed from the camera to the model, and then the model would respond, or AvidGenAI would respond if there is any rocks or dangerous road or any reason that would make this road dangerous. And you can see that the answer is basically the following. The scene depicts a dramatic and a dangerous situation on a two-lane highway. A massive landslide has completely blocked the right lane and so on. So it would go about on explaining what is wrong with the road. So the next step is it's about talking about AvidBeam and how AvidBeam is basically excels in this department. So AvidBeam, we basically strive on hardware optimization, and this enables us, to offer a best-in-class performance and offerings, as well as hardware quotations. AvidBeam also offers a Tune Studio for developers, and it basically what Tune Studio it enables rapid development for features and customizations, and this enables us to respond to clients, in a very short amount of time. AvidBeam also offers integration flexibility, like we integrate with many video management systems, IoT systems, and so on. And of course, AvidGenAI, it integrates well with our existing pipelines. Like I mentioned before, you can, leverage AvidGenAI and use it when it matters the most. So, and for our final thoughts that I have for you today, we are still definitely in the early adopters phase for video analytics applications. It's not fully spread out just yet. Edge processing is gaining traction recently, ensuring minimal latency, privacy, and security by design compared to cloud processing. So basically, you'll start seeing soon we'll start seeing more processing that occur within the camera itself. Hardware optimizations, of course, and accuracy, like we mentioned, are key towards reducing the total cost of ownership and, of course, staying competitive in the market. GenAI and video language models, VLMs, are indeed opening new doors for solving complex problems, but of course, they have their own set of challenges and complexity.
يعطيك العافية إسلام.
Thank you.
It was a fantastic presentation actually. طيب, to bring all this amazing technology to our client, we need a strong partner like you. Abu Umar, I would like to ask you a question.
Likewise.
How does solution-based CC today help customer in their AI transformation journey?
Perfect. So and thank you, Islam, for all the great information, taking us through the whole journey and why AvidBeam and your take on the whole thing. So for our audience today and for you, Akram and Islam as well, since AvidBeam is a subsidiary to the part of the solutions group, let's call it that way, and we're integrated and we're working together closely in most of the projects together in Saudi. Great thing for our audience is that what I'm trying to explain today is not that we only cover the video part or the video analytics part or the, let's say, AI gen for videos. Today, Solutions is your trusted partner to take the whole journey. The thing is that with our customer, they don't only look at certain use case. Most of the time, they're coming in, I want this use case, but they realize that they need infrastructure, they need Saudi residency. And I'm seeing a question here saying, is it hosted in Saudi? Can it be in Saudi cloud? So yes, this is definitely doable. We can have it in our cloud because we're offering GPU as a service. It could be in other let's say one of the hyperscalers in Saudi. We could help with that and have it all done. So you need someone like Solutions who could help you fix your data, have your data ready for AI, for video analytics, for example. Have your infrastructure ready. Do you want it to be on-prem? Yes, we can help you develop or implement that. You don't have a data center, we can create a data center for you. You already have a data center, we can have the right servers, the right GPUs, the right infrastructure, the right security. We can help you all with that. And this slide exactly explains that as Solutions, we help you from inspire to sustain. So we're talking about your digital transformation journey. We help you with the advisory of it. We help you set up your strategy, your vision, the KPIs, and so on, and have your right strategy in place. And then we help you with anything that requires system integrations from the different systems, from the different applications. We help you with connectivity, since we also offer connectivity services. You want satellites connectivity, you want MPLS, you want direct with the IA. All these is doable today with different services that we offer. You want to scale up, you say, okay, on-prem is too much, it's too expensive for me, maintenance is great, I'll have something small for my team. However, I want to scale, I want to grow big, less expensive. You go to cloud, we offer also our cloud services. We have one cloud marketplace. You can find lots of marketplace products there. You want to have co-location, you want to have hosting, you name it, our cloud services can cover you up. And then definitely we can disrupt your way of work with certain or latest emerging technologies, like we're talking here with AvidBeam, AvidGenAI. This is one of the disturbance that these new technologies is causing to the market. You want your AI strategy, you want your AI solutions, use cases, enable these AI strategies or AI use cases that you dream of. Even emerging technologies, we're talking AR, VR, emerging digital twin as well. So we help you with all of that. So I want our audience just to have this in back in their mind if they would reach out to us later on, that we can help you from your vision to operating the impact of that vision in the future. So this is a different type of services Solutions today is offering to their customers, to their clients. Hopefully the current ones, we will continue with them. And hopefully after this webinar, we'll have new customers to help you with your transformation journey, or to focus on certain use cases where we can enable the whole ecosystem for you. This is in general. I don't want to get in touch into all the services. We need to take hours to do that. However, this is in very brief the situation. Now coming to your AI journey, since we're having this series of webinars for AI, if we can go to the next slide, we can help you definitely from getting you ready to your AI transformation. We come in, we jump in, we do analysis, we do the use case, we do the business case where you focus on ROI. Let me tell you, many customers think that, okay, this use case is the right use case for me, and they want to jump in and have AI and lots of investment in infrastructure or cloud and so on. Why? They just need simple automation. So we do help you find your right way to go. We help you do the analysis, and we help you with the right use case to make sure that you're not using AI because you want to say I used AI, rather than you're using AI because you're making the right benefit, the right value, the right outcome out of using AI. So we help you getting ready to AI. We help you with the strategy, the vision, the infrastructure, GPUs,
you name it, either on cloud or on-prem or hybrid model. This is, we definitely help you with it. And then we help you manage and build your AI use cases. We do have the right capabilities. We have the right ecosystem from vendors to partners to our ecosystem of subsidiaries as solutions group. And then we help you power it up, right infrastructure, and to operate it with the right managed services offerings that we have. So we can cover everything you see in the slide, from the AI core stack to the AI enablement stack. And this is how we help our customers today having their AI transformation journey built into the right track, built into the right value that they want to reach. And one thing I always close by is that at Solutions, we're not thinking of doing a project or doing an agreement and we just do it because the sake of doing it. No, we look at the value that we bring to our customers, and we try to have our ecosystem into this value chain where we can cover you up from vision or dream to actual operations at the end. This is in very short how Solutions and how we can help our customers in their AI journey and AI transformational journey. And as we had the pleasure today to have Islam with us here, this is only focusing on video analytics. It's true.
Likewise, Mohammed. Likewise.
Had lots of great use cases, lots of great, let's say, success stories with many clients when it comes to video analytics and all the different ecosystem around that.
يعطيك يعطيك العافية بعمر. You can summarize it. We are solutions. We will find the solution for our customer إن شاء الله. يعطيك العافية Islam. So thank you بعمر. We have now a few minutes for the questions. Please drop your question in the chat and we will answer it.
As I mentioned, there was a question, by the way, it was shared that says, is AvidBeam solution can be hosted with local cloud provider in compliance with data residency requirements? I'll say yes, but maybe you can elaborate more, Islam, on this.
Yes, yeah, true. AvidBeam solution can definitely be deployed on the cloud and also locally in compliance with data residency.
Also here, Abdullah said, do we need to buy complete new cameras to use AvidGenAI, or can we work with our existing cameras? I think
any capable IP camera would work. So basically, clients or customers, they can leverage their existing IP cameras infrastructure, or even if they do have video management systems, AvidBeam platform can integrate with them immediately.
And here, Assad. Okay, I think this. Let's. I will read it. What is the biggest challenges the companies facing when they try to adopt an AI, and how does Solution by CC help them to overcome? I think this is for Abu Omar. Yeah.
Allow me to answer here, and this is something we usually we have done this and explained it in very detailed in the previous webinars. But to sum it up, the biggest challenges today are marked as two main problems. One is data. Data is always a problem when it comes to AI use cases. So if you want to start your, let's say, AI transformation journey, think of that doing your data transformation journey part of it. Because if you don't have data ready, you cannot have AI ready for that. The second largest problem that most governments, or let's say, I wouldn't say governments, most customers face today when they're trying to enable AI and have the AI solution is infrastructure. It's very expensive to have a data center with GPUs. It's very expensive to maintain, to acquire, as well as it's very expensive on the run, and the ROI usually is difficult. So this is the two main challenges companies face today when they want to start their AI journey. How we can help them? For sure, we can help them big time. But as I mentioned, we set up their AI and data strategy. We focus on the value that these use cases, AI use cases, would bring into the company against the spending that they will do. So we wouldn't do everything day one. We would analyze, we would assess, we would build a business case and the ROI out of this, and then say, this is a great use case that we need to invest, and this is the ROI of it. And then we kick it off and have it implemented. Infrastructure, as I mentioned, are the first MCP, which is the NCP, NVIDIA certified partner in the region. And we offer GPU as a service in our cloud, so you do not need to worry about infrastructure. We can help you with our cloud that is hosted in Saudi, it's located in Saudi. So regulations, compliance to regulations, all those data residency things will be 100% compliance with these regulations.
يعطيك العافية أبو عمر. I think that's all the time we have. Thank you, Islam and
Thank you,
Abu
Akram.
Umar, for a great session. And thank you to you, everyone who joined the webinar.
Thank you,
Have
everyone.
a wonderful day, inshallah.
Thank you, everyone. Thank you all.
Thank you, Islam. Thank you, Akram. Have a nice day, everyone. Assalamu alaikum.
Have a nice